intro. As Florence said, my name is Jason Richmond. I help lead enterprise sales at Safegraph. I want to welcome everyone to our session on spatial data science for economic forecasting. I also want to thank you, Carto, for hosting this event and being a great partner to Safegraph. And as I mentioned earlier, we're joined here today by our friends at Goldman Sachs, David Mericle and Ronnie Walker. So for the next 30 minutes, we're going to cover the impact of alternative data on economic forecasting. We'll then discuss economic forecasting in these unprecedented times of COVID-19. And finally, the importance of geospatial and alternative data. And then we'll leave some time open for Q&A. So now I'm going to hand it over to either David or Ronnie from Goldman Sachs.
All right, thanks very much, Jason. Great to be participating in this. And it's been a really interesting year for us making use of economic data. So I'm David Mericle. I'm the chief US economist at Goldman Sachs. And, I would say before the pandemic, our team never really made any serious use of alternative data. When the pandemic started, things started moving so quickly, the economy started changing so quickly that it became clear that waiting around a month or two for the official government data wasn't really an option anymore. And in the US, we have such rich and such high quality official government data that it was pretty hard to justify looking at some of these new alternative data sources before the pandemic began, because the signal to noise ratio usually wasn't really impressive enough to compensate for the being maybe 2, 3, 4 weeks earlier than you get from the government. But once we really needed to know, is GDP down 5% or 25% a couple weeks into this pandemic, we started looking at all sorts of new forms of data. And some of these were very crude. For example, we would just browse through press articles to try to get a sense of how much is this or that manufacturing industry shutting down. Some of it was more sophisticated, for example, making use of mobility data and trying to translate that into something that was actually comparable to the official government economic statistics that we're all used to using. Today we have with us my team member, Ronnie Walker, who's led our efforts and has produced a wide range of tools that we've relied on and our clients around the world have relied on over the last year, and that have allowed us as a team to really give a sense in real time of just how quickly things were turning down, but also to call the recovery very early on. Our group was very early in calling the magnitude of the downturn, but also since June of last year, we had a sense that growth in 2021 was going to be much, much stronger than anyone was imagining at the time. And I think ultimately what alternative data really allowed us to do was to see that this crisis was very different from our usual model of the business cycle, that the speed in particular of the downturn and of the recovery really had to be substantially rethought and to craft our forecasts accordingly. And that served us very well. So enough of the generalities. I'll let Ronnie talk a little bit about some of the specific tools that we've developed.
I want to just start by defining what I think of as alternative data. So alternative data to me is basically everything that isn't traditional data. What is traditional data to an economist? Like David said, it's all the data series that are produced by the government statistical agencies, the Federal Reserve, and kind of pseudo-official organizations like ADP. So for data series, things like the unemployment rate, the consumer price index, and GDP. And alternative data is everything else. So that's a very broad definition. But in our job, some examples would be geospatial data or credit card spending data, or data derived from some kind of text analysis. And our team is always looking for ways to make better predictions, like David said. And that's kind of the reason why someone in our position has turned to alternative data. So the pandemic has accelerated the drive toward alternative data for 2 reasons. One, things are happening much quicker in the economy than usual. Lockdowns only take an instant to implement. So being able to quickly know the impact of those kinds of changes has really placed a premium on timely data. And alternative data can be significantly more timely than traditional statistics. On this slide, I have a timeline that one of our colleagues made. All of the bars on this chart represent the typical release date for different economic indicators corresponding to a given reference month, or the month of activity that the economic indicator is describing. To make this more concrete, use a specific story. Let's say that the reference month is January. So January is to the left of the dotted line on this chart. February is to the right of the dotted line. If I wanted to know the total value of goods that were exported in the US in January, I could wait for the advanced goods trade report from the Census Bureau, which reports the official number, but that comes out at the end of February. And that's the bar on the far right. Or if I wanted an earlier read on exports, I could start to infer it from some of the other official data releases that come earlier in the month. For example, we know that the manufacturing sector is exposed to international trade. So if activity in that sector looks weak based on some of the Fed's regional manufacturing surveys, we might assume that goods exports will look a bit softer. But all that seems less than ideal. So this is a situation where alternative data helps us out a lot. We've created what we call our export tracker. And in this timeline, our export tracker release dates are the bars that are sticking down. And the dates that each release corresponds to are the shaded area that you can follow back. The tracker combines bill of lading, so like ship manifests, with some in-house geospatial data that tracks cargo ships leaving ports. That gives us a more direct read on the value of exports and gives us a much shorter lag time. You can go to the next slide. The second reason that the pandemic has accelerated the drive toward alternative data is the size of swings that we've gotten in the economy, like David said. One of the main struggles with alternative data is that it can be a bit noisy. So as an example, we think that the economy should grow around 2% per year in normal times. So that means that on a month-to-month basis, the economy is growing relatively consistently around 1 to 0.2% per month. In some alternative data sets, though, there can be seemingly random swings of a couple or more percent per month. And that just makes them not all that useful when trying to forecast the path of the aggregate economy. But the pandemic definitely changed that. So in April, you saw a 5% decline in GDP, or in March, you saw a 5% decline in GDP. In April, you got another 10% decline in GDP. And so if you're off by 1% or 2%, yeah, it's not that big of a deal. You kind of really want to gauge initially how much of a decline you got, and this will give you a kind of more timely read. So because of those two reasons, we created a bunch of new tools for assessing the economy during the pandemic. And in this section, I wanted to run through some of them. Some of these projects range from tools where it's just like us collecting alternative data that's already out there, but might be less well known or helps us form a long-term view about the direction of the economy, to tools where we're taking existing alternative data sets and combining them with traditional data, or all the way to where we're kind of creating a data set ourselves and then getting some sort of insight from it. So this tool on this slide is an example where we just borrow some other people's alternative data to help us form a long-term view about the economy. Traditional bankruptcy stats come out with significant lag, something like months to quarters, which in normal times isn't like such a big deal because the stats are relatively persistent. But during the pandemic, it's something that we've really been worried about, an increase in bankruptcies. Bankruptcies are a sort of scarring effect on the economy. We thought of the pandemic generally as a sort of temporary shock. So when the pandemic or lockdowns are over and life returns to at least a somewhat normal state, if businesses are still in place, it means that people can return to the labor market much quicker and output can pick up faster. So if you look to the chart on the left, on the dark blue line, which is the Bloomberg BCY measure, it's based on legal filings, but it only tracks large companies. That surged in the early days of the pandemic. A lot of that reflected large companies that were already in not so great financial shape before the pandemic, undergoing some kind of restructuring. On the other hand, if you look at the dark blue line on the right, which is from the American Bankruptcy Institute, it's also a measure based on legal filings, but that tracks the whole economy. You can see that that has remained extremely low, in part because of the unprecedented fiscal stimulus that we've gotten throughout the recession. So that information has been helpful for us in maintaining a fairly optimistic view about the speed of the recovery of the US. We can go to the next slide. This next tool is just an example where we combine alternative data with traditional data. It uses Google mobility data, which I'm sure you've seen a million times, but it combines that Google mobility data with data from the census on county population densities to show how mobility differs across small to medium to large cities. So our team lives in New York, and this project from back in September was mainly just a cross-check to see if our experiences were similar to that in the rest of the country, and to get us a bit out of our bubble. And looking at this chart, you can see that mobility dropped more sharply at the beginning of the pandemic in areas with a higher population density, and they remained depressed relative to the rest of the country. The same was even more true for New York. So the takeaway there was that when we look out our windows, we probably didn't want to project our experience on the rest of the country. We can go to the next slide. So this is a tool, like this next tool is a collection of alternative data series from third parties that were either based on credit card spending or foot traffic. And we use them to measure consumer spending, which makes up 2/3 of GDP. So it's pretty important to an economic forecaster. If you get consumer spending right, you're going to get GDP at least partly right. Our value add here was that with the data series that had some sort of additional granularity, we tried to match that additional information to the national accounts. So as an example, if we take Second Measure, a credit card data set, we matched their industry level data at the 6-digit NAICS code to the most granular level of personal consumption in the official statistics, and use the weights in the official statistics to get a more accurate picture. Why would we want to use the official weights? An easy example there is that a lot of people don't pay for housing with their credit cards, but that is something that's captured in the national account, and so we'd want to adjust our measures accordingly to compensate for that. You can go to our next slide. So this next tool used SafeGraphs data. We wanted to know how college towns had fared during the pandemic. Those towns typically have a large share of the population come and go throughout the year. But with the pandemic, the vast majority of universities closed in the middle of the spring. So we wanted to know, one, how quickly economic activity dropped off in those towns, and two, how they were doing during the fall when we ran this exercise. In the chart on the left, we measured visits to businesses in college towns relative to businesses in the rest of their respective states, and centered that activity on the day that they officially closed. And somewhat unsurprisingly, you can see a sharp drop in activity following the day that a school closes. On the right side, we ran the same exercise for the middle of the fall semester, but grouped schools by the reopening status. Once again, unsurprisingly, we find that economic activity had normalized by a greater amount in schools that had opened to in-person instruction, and by less in schools that were completely remote. But also, another takeaway is that on net, college towns are still, we're still seeing less activity relative to the rest of their states. This analysis was useful in that it helps us kind of see the distribution of outcomes in the economy. We showed a few slides ago that bankruptcies had fallen in aggregate, but what this exercise shows is that there were pockets of weakness in the economy, or there are certain industries or sectors that were more vulnerable to this kind of shock. You can go to the next slide. So this brings me to the last tool that we're going to show. This is our Twitter sentiment index. In it, we search the universe of tweets for ones that include something related to the economy, and then we run sentiment analysis on the individual tweets, and then take the difference between the share that read in positive and the share that are negative. So an example of a tweet that would be something like, "Ah, dang, I just got fired for giving a terrible presentation. What am I going to do without a job?" And that tweet would probably be evaluated as negative, and it would weigh on sentiment in our measure. Why is that helpful? Consumer sentiment is highly correlated with consumer spending, and this tool gives us an almost real-time read on consumer sentiment. So in the beginning of the pandemic, as you can see in the chart on the left, there was a sharp drop in our measured sentiment, and that was kind of our first read that there was going to be a big hit to activity. What's nice about this tool is that you can directly observe the topics that are leading to a more negative perspective. So with traditional sentiment surveys, you kind of have to infer what's driving the change. But as the chart on the right shows, we're able to see emerging negative topics and try to quantify that impact on consumer sentiment. So that's kind of nice. So that's all from me, but just to end less abruptly, the theme across these projects is that we had some kind of question about the economy. And in each of these cases, we built out the strengths of alternative data, that they're timely and that they can give you additional granularity. It's not available in the traditional economic statistics, just to get a better answer to those questions. Thanks, and with that, I can pass it back to Jason.
Awesome. Thanks, Ronnie and David. I'm now going to talk about the importance of geospatial alternative data. So a lot of what Goldman has spoken about on the previous slides, highlighting the various tools during the pandemic, a lot of that has a geospatial component, which is where myself and SafeGraph focus most of our efforts with our financial services partners. Now, as many of you know on this call today, there are hundreds of alternative data providers, some of which include credit card data, point of interest data, mobility data, weather data, satellite, and social sentiment. Now, no single data set, as Ronnie highlighted, is the end-all be-all in terms of signal for an analysis. We at SafeGraph believe that the real power comes from joining these disparate alternative data sources together to build a thorough analysis, for instance, on a single name equity such as Starbucks or Walmart. At SafeGraph, we are actually a founding partner in an open coalition called PlaceKey with Carto, which is a universal place identifier or join key for every place in the world. And the goal there is to make it easier for data science teams to consume data and easily merge data sets together before preparing it for analysis. Now, it's important to note that not all geospatial data is created equal, and not all suppliers of data are maniacally focused on being data companies. Some companies are focused on providing solutions and analytics, and a lot of companies are focused on really just having broad coverage over quality. And while there's a fine balance between the two, what I'm going to highlight over the next couple of slides is that SafeGraph, we've really focused on data veracity for our partners. And data veracity is really important to economists like David and Ronnie because it improves economic forecasting. Now, some of you may be wondering exactly like, what is SafeGraph? SafeGraph is a data company. We are maniacally focused on building facts or data files about the physical world. We don't do the analysis. We don't provide software. We'll leave that up to Carto. But we really just want to focus on curation, validation, and transformation of places data so that our customers can really focus on building derivatives, which is models, insights, and really amazing economic outlook reports that the Goldman team is producing. Now, as a pure play data business, over the last couple of years, our mission has been to democratize access to clean data to drive innovation. So we are pretty horizontal, similar to Carto. We're not just working within financial services on both the buy side and sell side, but we're also working in industries such as logistics, GIS, ad tech, and real estate. As you can see from our slide here, we have PE firms that are using the data for deal sourcing, diligence, value creation for various portfolio companies, but we'll also partner with large CPGs or FMCGs who are incorporating SafeGraph places and mobility data into demand forecasting models to optimize supply chains. Now, the next slide actually highlights some of the SafeGraph products. You can see that we are a leader in places data. So we have over 7 million points of interest across the US, Canada, and UK. We cover both branded national chains and non-branded places. And we have very good category balance. We have strip malls, airports, fulfillment centers. If you want to look at warehouse utilization, that could be a good use case. And we think of sort of place data in a couple of different ways. So first, it's important to have like the core POI information about a business. So an economist like Ronnie or David could monitor the open and closing dates of various businesses across these geographic regions, having precise building footprints or polygons and accurate geocoding. And then the data sets that got the most popularity during the pandemic were our mobility data sets, where we provide aggregated, anonymized foot traffic to stores across these different regions. But then we also have a zoomed out version at the census block or neighborhood level. It's very interesting, actually. SafeGraph was donating a lot of this data to various researchers and thousands of epidemiologists and the White House and CDC to actually use mobility to detect COVID-19 hotspots and figure out, where to open up different parts of the U.S. economy. Now, another really exciting update I want to call out is we recently moved into the UK. We're now offering SafeGraph's core places and geometry data starting next quarter. Our long-term goal is to provide this data for the entire world. And our next step in that is to provide this data for England, Scotland, and Wales. And, just look out for updates on our website. We will be going into some other regions over the next couple of months. I also want to call out that the patterns data that you saw on the previous slides and what you saw Ronnie walk through is available in Carto's spatial data catalog. So it's right there. It's ready for users of Carto to start building analytics in real time. It will have key variables like number of visitors, brand visited, NAICS code, geocoding information. And so folks that are using Carto today can really get a sense of where populations are flowing throughout these various regions and how that's having, how COVID is having an impact on the economy. Finally, if you're interested in our other data sets that are not in Carto's spatial data catalog, You could, of course, reach out to our sales team, or you could visit our self-serve data shop at shop.safegraph.com. And I'll call out that about a week ago, we launched our beta version of our API. So you could also pay as you go if you would like. I'm now going to turn it over to Florence to open up the session for Q&A.
Thank you very much, Jason. Thank you, Ronnie and David, for joining us. It was really great to hear what you guys are doing at Goldman Sachs and Geospatial. I think we do have one question in the chat. I think Ozzy Castillo would like to know a little bit more about how data is collected. Maybe, Jason, you can share a little bit more about that.
Yeah, so if we're speaking within the lens of SafeGraph, I'm happy to give an overview of that. So to first get an understanding of a place, SafeGraph takes in data from thousands of diverse sources. So we have our own crawl systems where we're looking and scraping various websites. We'll look at open and municipal data sets. We'll work with third-party data sets. And we'll also do object detection via satellite imagery. And we're really good at taking all these different sources together, cross-referencing them, algorithmically QAing them, and then making sure that we merge them accurately while discarding bad data. That's how we get to a single sort of record of truth to know this Starbucks or this strip mall exists at this point in time. Now, once we have a deep understanding of a place, we then want to draw polygons and having a precise building footprint around each individual record in our data sets. And then finally, to get mobility data, we work with a deterministic panel of cell phone GPS data, where we get GPS signals from hundreds of privacy-compliant mobile applications that have a clear value exchange with consumers to ask for location collection. So we see a combination of background, foreground GPS pings, and then we basically have to run those signals through density-based clustering algorithms, as well as learning to rank algorithms. So essentially using machine learning at SafeGraph to accurately resolve where those cell phone pings are in the physical world. And then we just aggregate that data up so that it's privacy compliant, leverages differential privacy techniques, and we really just represent that as counts to our partners.
Fantastic. Thanks for the explanation. I think there's a couple more questions as well. So Anton Muller, I think he is asking about services outside the USA. You mentioned the UK, which I think is launching later this year. Are there any others on the roadmap, or can that not be shared?
Yes, so we have US, we have Canada, the UK MVP comes out in April. So that will be live. And then I don't want to future sell or get my product team in trouble, but usually when we go into a new market, it's driven by our customers. We work with very large partners like Microsoft and Amazon and some others. So we're actively sort of stack ranking those geos, and you'll see us move into maybe other parts of the EU as well as APAC later this year.
Fantastic. And then Peter Elliott would like to know if SafeGraph data maintains unique place IDs for residential areas.
Yeah, so we don't have any residential data in our data today, right? It's really focused on where people spend money and then time. However, in that place key initiative, place keys are available for every place in the US, right? Both commercial, industrial, and residential. And so they can access that place key API today. They can get place keys on a residence, like a multifamily asset in the US. And then there are various data vendors outside of SafeGraph who have appended place keys to their data sets. So that could actually make it very easy for them to discover new types of data about residential and easily merge that data, as opposed to doing some type of address matching. But if Peter has a specific question on getting residential, I'd love to connect with him after the session.
Brilliant. Fantastic. Well, thank you so much, Jason. Ronnie and David, again, thank you. Have a great day.